All right, welcome. Today, we're doing something a little different. We're staging a showdown between three of Earth's most powerful forces. We're going to see how experts actually compare them when the dust settles. So, let's get right into it. You've seen the headlines, right? Earthquakes, volcanoes, tsunamis, but which one is really the worst? I mean, if you had to pick one, which is the most dangerous, the most destructive? It's a question we've all probably asked ourselves.
Well, it turns out the answer is way more complicated than just picking one. To really figure this out, we can't just go with our gut. We need a special tool, a kind of, well, think of it as a judge's scorecard for natural disasters.
And that brings us to the geographer's toolkit. We're going to pull out a really cool tool called the hazard profile. This is how scientists can systematically break down and compare these massive events.
So, what is a hazard profile? Simply put, it's a framework. It lets us look at these different hazards side by side, using the exact same criteria. It's all about moving past just the fear factor and into a structured analysis. We're basically creating a stat sheet for each of our tectonic titans.
And these are our 6 categories for the showdown. We're talking about everything from sheer power, that's magnitude, to how much warning we get, which is the speed of onset. We'll also look at how big an area they cover, how long they last, how often they happen, and how well we can predict where they'll hit. Let's see how our contenders measure up.
Okay, the showdown is on. Let's run earthquakes, volcanoes, and tsunamis through our hazard profile, one category at a time, and see where each one's strengths and weaknesses really lie.
First up, aerial extent. That's just a fancy way of saying how much ground does this thing cover. And right away, we have a clear winner. Look, earthquakes and volcanoes can be absolutely devastating, but they're usually more localized. A tsunami, on the other hand, a single event can cross an entire ocean, hitting coastlines thousands of kilometers away. When it comes to sheer reach, tsunamis are just in a totally different league. Now, frequency. How often do they happen? This one's interesting. You can see earthquakes are off the charts. We have thousands every single year. But you know what? Most are so small we don't even feel them. Volcanic eruptions are less common. And tsunamis? They're actually the rarest of the three. So the takeaway here is that even though earthquakes are happening all the time, a single, rare tsunami can be catastrophic.
Okay, what about staying power? How long do these things last? Well, an earthquake is terrifying, but it's usually over in seconds, maybe a couple of minutes. A tsunami event might unfold over several hours as waves keep coming ashore. But a volcano, an eruption can go on for days, weeks, sometimes even years. So for just relentless long-term disruption, volcanoes are the undisputed champs.
How much warning do we get? This is speed of onset, and it's absolutely critical. Earthquakes are the textbook definition of rapid onset. They strike without any warning, and that's a huge part of what makes them so dangerous. Tsunamis are also really fast, but sometimes warning systems can buy us precious minutes to get to higher ground. Volcanoes, though, are often the opposite. They tend to give us clues, things like gas emissions of the ground swelling, which can give us weeks or even months to prepare.
So, can we predict where these things are going to happen? For earthquakes and volcanoes, the answer is kinda. We know the zones, right? They happen along known plate boundaries, like the famous Ring of Fire. The really tricky part is we just don't know when. With tsunamis, we also know they start in these zones, but their impact zone is way less predictable. A wave can travel in unexpected directions and hit a coastline you'd never expect.
And finally, let's talk about raw power, magnitude. For earthquakes, we have things like the moment magnitude scale. For volcanoes, there's the Volcanic Explosivity Index, or VEI. They give us a clear number. But tsunamis, they're a bit trickier. There's no single scale. We often measure them by wave height or energy, but that can change dramatically from one place to another. Okay, so we've run them through the gauntlet. We've compared all their characteristics. What's the final verdict? Who's the winner? And maybe more importantly, why does any of this actually matter in the real world?
And here it is. This is the big takeaway. There is no single worst hazard. It's just not that simple. The worst one depends entirely on what you're measuring. It's not about which one is bigger or badder. It's about understanding that each one has its own unique, dangerous personality. So let's just break it down like this. If your number one concern is a sudden strike with zero warning, then yeah, the earthquake is the worst. If you're worried about the sheer geographic scale of the disaster, it's got to be the tsunami. And if you're thinking about a disaster that just will not quit, then the volcano takes the crown. Each one is the worst in its own special way.
And this is why it all matters. This isn't just some interesting academic exercise. Understanding a hazard's unique profile, its speed, its scale, its duration, that is the absolute fundamental key to protecting people and saving lives.
So here's how it works in the real world. Planners use this exact process. First, they profile the hazard. They know an earthquake's profile is rapid onset, so they prepare by designing early warning systems and building earthquake-resistant buildings. They know a volcano's profile is slower onset, so they prepare with evacuation plans and by monitoring gases. That specific preparation, tailored to the unique personality of each hazard, is how we protect communities. It's how we reduce risk and ultimately how we save lives.
So we've seen how profiling these giants helps us understand them, not as just random monsters, but as complex systems we can prepare for. It's an incredibly powerful tool, but it does leave us with the biggest question of all. As our science gets better and our profiles get more detailed, what's it going to take to finally crack the code? To predict not just where they'll strike, but exactly when. Now that is the next frontier. Thanks for joining me.